For the first one, x squared minus 4x minus 21, you would have wanted to factor this one. Factors of 21 that subtract to give you 4, and then set those equal to 0 and solve. So you would have gotten negative 3 and 7. And then factor 51 as well, factors of 30 that add up to 11, and then set those equal to 0 and solve. You would have gotten negative 6 and negative 5. For 53, this was actually a special case. If you remembered how to factor this, you could have. Or you could have just solved by getting the square by itself and taking the square root, just like you did for your quiz. You could have added 64 and divided by 9, which was just a fraction, and then take the square root of 64 over 9. And you would have gotten positive and negative 8/3. And then for 54, you want to make sure that it's equal to 0 before you factor. So add that 9 over, and then you'll want to multiply across and do your rainbow method to factor. Or if you recognized it's a special case, this was a perfect squared trinomial, and you got negative 3/2 for both of your answers here. So for 53, unless you remembered your special case factoring, you can take your 9v squared minus 64 and add your 64 over. You would get 9v squared equals 64. Divide by that 9. So you have v squared equals 64 over 9. At this point, just like in your quiz, you're going to take the square root of both sides. So you'd say square root here and square root here. Remember, when you do a fraction, you just take the square root of the top. So square root of 64 is just 8. And the square root of the bottom, the square root of 9 is just 3. And anytime you have a variable squared and you're solving for the root, you have to remember it's the positive or negative root. Just to kind of recap what we're looking for when we solve quadratic equations, is you are looking for what makes that equation true, just like any other algebra equation. If you have the variable x equals a number, that means that you should be able to plug x into that equation and it makes a true statement, okay? And so for all of the things we've been doing, we're trying to figure out what x value makes this equation true. The first way we did it was in our bell work, where we just solve for the square and take the square root of both sides. And then you can plug in the positive and the negative square root there, and they should both make that equation true. The next thing we did is we looked at when you had ax squared plus bx plus c, you had all three of your standard form, and we could factor it. And so we were like, oh, factors of this that add up to that, make your groups and set your groups equal to 0. And then when you plug those back in, that will make that equation true. Then you run into cases where it's not easy to factor and you can't just get the x squared by itself. And when you have those occasions, you're going to then go to the quadratic formula, all right? And so the quadratic formula will actually work for every one of these types of solving. However, sometimes the other ways are easier than quadratic formula. So the first thing you want to notice is they give you the quadratic formula. So we're going to talk about each piece of it and how you get it. All right, so they've given us the standard form of the equation, which is ax squared plus bx plus c equals 0. You will notice that just like with factoring, to use the quadratic formula, it has to be equal to 0. If it is not, you have to move everything over so that it is equal to 0, or you cannot use the quadratic formula. All right, your a's, b's, and c's. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. It seems complicated, but it's just a memorization. Negative b plus or minus the square root of b squared minus 4ac over 2a. So negative b, we're going to take the b and we are going to plug it in right here and make it the opposite value. If it's a positive, make it negative. If it's a negative, make it a positive. Plus or minus b squared, you're going to plug b in again. All right? Minus 4, it's always a 4 there, times AC. You're going to take your A and your C, and you're going to plug those in accordingly. And then all over the whole thing, that numerator, over 2 times a. And you're going to plug a in right there. That is the quadratic formula. You have to memorize that formula because you will use it to solve. Okay? So let's look at it in use. Let's actually solve a problem using quadratic formula. All right, they have given us x squared plus 6 equals 5x. Okay? So the first rule of the quadratic formula is it has to be equal to 0, all right? And so this one is not equal to 0, so I have to move this over. And I'm going to do that by just subtracting. So I'm going to take my original. I am going to, actually, it was already a positive. All right, I'm going to subtract my 5x over. All right, the left-hand side, I need to combine like terms. Well, I don't have any like terms. So I do want to write it in standard form. I want my x squared first, ax squared. My bx is next, so negative 5x. And my c is last. I do want it in standard form. And on my right-hand side, I have 5x minus 5x. I now have it equal to 0. Now, I want to point out that they have given us one that you could potentially factor. Hopefully, right? So we have factors of 6 that add up to give us 5. This is one that's easily factorable. So if I just gave you this and said solve, and I didn't tell you what method to use, you may say, oh, well, factoring is easy. But if I give this to you and say use the quadratic formula, then you have to use the quadratic formula. But they've given us one where you can see that they both work, all right? So if I were to factor this, how would I factor it? 3 and 2, right? So now we're going to use the quadratic formula, and what we're looking for is we should get those answers when we use the quadratic formula, all right? So we're going to first figure out what our a, b, and c is. Our a is the number in front of x squared. So what is our a?
1.
A 1. So this is my a. What is my b? Specifically, negative 5. And what is my c? 6. And now I'm going to use this formula right here and plug it in. All right? So it says negative b. Well, I already have a negative 5, all right, as my b. So negative b is going to be just 5. Then it's plus or minus the square root of b squared minus 4 times a times c. And that whole thing is over 2a. Once you've plugged it in, you are going to use order of operations. All right? So we're going to do our exponent first. Then think of the square root as a group. Think of the numerator as a group. All right? And so we're just going to use order of operations. So I'm going to rewrite this, and I'm going to say 5 plus or minus. What is negative 5 when I square it? 25 minus 4 times 1 times 6 is 24. All over 2 times 1, which is 2. And I'm going to keep simplifying it. 5 plus or minus 25 minus 24 is 1 over 2. All right? Obviously, the square root of 1 is just 1. Now, I need to actually do the process. 5 plus 1 over 2, 5 minus 1 over 2. All right? Because I can do that. If it were a square root, I couldn't. So I'm going to say 5 plus 1 over 2, 5 minus 1 over 2. 5 plus 1 over 2 is 3. 5 minus 1 over 2 is 2. So that means x can equal 3 or 2. Now let's go back to what we said about factoring. If I factored this, I would get x minus 2, x minus 3. If I set each one equal to 0, I would get 2 and 3. Okay? Now, again, they gave us one that you can factor. Factoring would have been easier here. I will give you that one, all right? Factoring would have been easier. But typically you're going to use this when you, 1, don't have easy factoring, or 2, you can't factor it at all, all right? And so if you have a very easy factoring and I don't tell you a specific way to solve, you would probably choose to factor. If I give you a more difficult one and I don't give you a way to solve, you may use the quadratic formula. All right, but they've given us one that we can actually see because we're going to get to ones that you cannot take the square root of. So I want you to actually try check understanding 1A and B. All right, so the first thing you want to do is establish what your A, your B, and your C is. All right, what is your A? 1. What is your B? -2. And what is your C? -8. So we're just going to plug that in. Negative B plus or minus the square root of B squared minus 4 times A times C, the whole thing over to A. So first step is just plug it in. Then we're just going to use order of operations to solve. -2, that's just a 2. -2, when I square it, is 4. Minus 4 times 1 times -8. That's -32, right? All over 2 times 1, which is 2. Simplify it some more. I have minus a minus here. So what do I do there? 4, yeah, plus 32 over 2. So I have 2 plus or minus the square root of 36 all over 2. I know what the square root of 36 is. What is the square root of 36? 6. So I'm going to say 2 plus 6 over 2, and 2, I wrote it both ways, minus 6 over 2. All right, so 2 plus 6 over 2 gives me what? 8 over 2, which is 4. 2 minus 6 over 2 gives me what? So 2 minus 6 is -4 over 2, which is -2. So x equals 4 and -2 for that one, which is the answer you get. All right, so I have to get this equal to what before I can even start? 0. So I need to move that 117 over. So you get x squared minus 4x minus 117 equals 0, right? So my A is what? 1. My B is -4, and my C is -117. And then I am just going to plug it in. Negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times A, right? And then I am just going to do order of operations. It's much bigger, obviously. I would not give you a huge number on a test where you had to do all this, but -4 is +4 plus or minus 4 squared, -4 squared is 16. What did you get when you got 4 times 117? Anybody get that? 468, hopefully, right? And it's minus a negative, so it's plus 468 all over 2. I am not going to give you these huge numbers because you likely will not. We haven't done square roots, real big square roots yet, so I won't give you something that big. If you got to this point, then you're doing well. 4 plus or minus the square root of 484 all over 2. I would not make you take the square root of 484. So, but if you got to this point, you're good. All right. I will give you something that you either know the square root of or you know it doesn't have a square root. We're not going to approximate them. I don't want you to try to figure it out. I want you to just leave in radical form. So I want you to understand that term. Radical form means leave with the square root in your answer. Okay? And so that's what we're going to do. If it does not have a perfect root, we are going to just leave it in radical form or in root form. All right? We're going to do the same thing. We're going to figure out our A. We're going to figure out our B. And we're going to figure out our C. This is already equal to 0, so we're ready to plug it in. Negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. All right? And then we're just going to simplify. Negative 4 plus or minus 4 squared is 16. Minus a negative, so it's going to end up being minus. When I have a negative and a negative, it's going to end up being positive, right? So 4 times 2 times 7. What is 4 times 2? 8. 8 times 7 is 56. All over 2 times 2, which is 4. And then we're going to simplify that. Negative 4 plus or minus. You need to add the 16 and the 56. What is 16 plus 56? 56 plus 10 is 66. Plus another 6 is 72. Yes, hopefully 72. All right, does 72 have a perfect root? It does not, right? I mean, we know that if you just go through it, like 8 is 64, 9 is 81. So we jumped over 72 when we got our perfect roots, right? So this doesn't have a perfect root. In the next chapter, we're going to learn how to simplify roots. But at this point, if it does not have a perfect root, that is your answer. If it does not have a perfect root, you are finished. That's all you're going to do with this, okay? As we add a little bit more next chapter, then you'll see where you can simplify that in like Algebra 2. But at this point, that is your answer. If it does not have a perfect root, you're done. If it has a perfect root, you need to add it and divide, subtract it and divide, all right? So I want you to do these, and I want you to leave them. Leave them the way they are. And for right now, we're just going to do A. And then we'll work through B. 49. So we have done several methods to find these same answers. Graphing is one that you're going to have to graph for me, but I'm never going to make you answer what x equals using a graph. Because when you use a graph, unless you use like a graphing calculator or a graphing program, your sketching of a graph can be off. And so it's not a very good method to solve when you're just doing basic solving here. But you will have to graph for me. Taking the square roots. This is the way you want to do it if you don't have a b, all right? So if it's just ax squared, there's no bx, but there's a c, that's when you want to solve by getting the square x squared by itself and taking the square root of both sides. So that method you will use to solve. That's when you do not have a bx, all right? So these will look like just ax squared plus c equals some number or equals 0, all right? That's when you will want to get the c over, and this is just or some constant. Any constant is fine. Get the c over, divide by a. All right, factoring. You will want to use factoring when you have something that's very easily factored, all right? If you can easily factor it and set each group equal to 0, solve by factoring, all right? And then we're not doing completing the square. We will do that in Algebra 2, so don't worry. All right. The last method that you will use for me is using the quadratic formula. So quadratic formula is if you cannot factor it easily or it can't be factored at all, all right? So if you get ax squared plus bx plus c and you can't factor it, then you want to use quadratic formula. Specifically, I want to point out that for square roots, not for square roots, but for factoring and for quadratic formula, they have to be equal to 0 to start that process. All right, so if you factor or do the quadratic formula, it has to be equal to 0. All right, so let's look at some of the examples that they give us on the next page. Easiest way to solve these. So if I were looking at A, we do not have a bx. I would just add the 6 over and divide by 2. All right, and then I would have the square root, positive and negative root of 3. All right, for B, that does not look like something I want to factor. So I would probably use quadratic formula there. All right, C, that looks like something I could factor. Factors of 15 that subtract to give me 2. I'm just going to factor it and set each factor equal to 0. All right, 16, I will never give you numbers that big, but I would not want to factor that guy, right? If you look at this last one, factors of 4 that add up to 7 don't exist, all right? So you would have to use quadratic formula there. There are no factors of 4 that add up to 7, okay? And so if you get one like that and you're like, I don't know how to factor it, go straight to quadratic formula, all right? Quadratic formula will always work. And that's why it's so important to know your methods, because path of least resistance, use the easiest one for whichever one you have. All right, any questions?